In this video, we are going to talk about some measures of dispersion. The dispersion is very important. We usually combine this dispersion or measures of dispersion together with the measures of central tendency to see what's the data look like in a broad picture or in a detailed pictures. Okay, so the important thing about dispersion is that we use a dispersion to see how data spread along with around the mean. So the example here, I use a sniper. Let's say we have like two snipers. One sniper has a training score like 99989. So if you combine them together, the total will be 44. And if you divide it by 5, the average will be 8.8, which is a good score, right? Now, if we have another sniper who, when doing the training, he got 10, 7, 10, 7, 10. So the total is still 44, just like the sniper A. The average is the same, like 88. Now the question is, who might be the better and who would you choose for mission, right? So you can see it from a broad picture, they have the same total and they have the same average. So the thing is like here, a common people or normally people would pick the first one, the sniper A for the mission, because he seems to be more stable in shooting, right? Compared to the sniper B, well, since the sniper B can do very good job, but also he can do some bad jobs like 7 as well, right? So based on your instinct, you will usually pick the sniper A. If we picture it, so you will see the blue line shows the sniper B, and the red line shows the sniper A. So sniper B has a like up and down when the sniper A is very stable. So now common people would pick the sniper A. Now what the stats told us is that we have the average and we have another number followed by the average. Whether it's plus or minus, those the numbers is something we are going to learn in this PowerPoint. Okay, it's called the standard deviation. So I would usually choose the sniper A for the mission because the sniper A it seems more stable. When the sniper B is not that kind of stable, well, he may shoot 10, but also there's a likelihood that he will shoot for 7. But the sniper A is quite stable. He will definitely get like above the 8 and around 9. Although he cannot really shoot a 10, but it's very stable. So usually people will pick the sniper A, right? So now that's for the continuous variable. The very first thing in this PowerPoint is we are going to talk about the measures of dispersion in nominal and ordinal variables. Nominal and ordinal variables, in other words, we learned it before, is that they all called categorical variables, right? So variation ratio is one of the measures, or we usually use like the VR to measure or to call it variation ratio. It only measure of dispersion that can be used with the nominal and ordinal. Now, although you will see like there is a bunch of sentences in here, but basically what it's talking about is that if you have the data that is nominal and ordinal, like a variable or something like that, so you have to make sure that you add everything together, every frequency of the value together must be the total sample size. The same thing that we did in the previously is that if you add all the proportion together for each value within this variable, then it's supposed to be 1. Okay? And also for the percentage, that is supposed to be 100%. So it's very easy to understand that you don't even have to learn what is stats look like, and you will naturally know to solve those problems. For example, in a sample, 55% of a sample is female, and what percentage is male, right? 45. So you got to make sure that those two add, it must be like 100%, right? So similarly, in this sample, the defendant sample, 96% of defendants in a sample were convicted, and what's the percentage that are not convicted, right? 4%. So you have to make sure that when you add those things together, it must be 100%, right? So a judge choosing from 3 sentencing options give 70% of defendants jail time, 20% probation, and the remaining what is just simply paying the fines. 10%, right? You have to add those things, everything together. So it must be equal to 100 because there are 3 sentencing options. So the variable is sentencing options. The values are jail time, probation, and fines, and you have to make sure all the proportion of those value you add them together is supposed to be 1, and all the percentage of each value you add them together is supposed to be 100%. It's quite simple, right? So for the measures of dispersion in interval and ratio variables based on the previous PowerPoints, we call them continuous variables. Continuous variables are more likely to be represented by simple numbers, just by the numbers. Okay, so very first thing we're going to talk about is a range. Range is a very simple measure of the dispersion for a continuous variable. Okay, so usually we use this big R to represent the range. And the range is very easy to be calculated, and it will be calculated by using the raw scores. And as you can see, the formula down here is the range equals to the largest value or largest raw score minus the smallest raw score, or the maximum x minus the minimum x. Okay, it's quite simple. It's just the biggest minus the smallest. So here we can see this table shows the number of juvenile arrested for homicide by different state. That is in 2012, right? We have all those states, and we have the juveniles who are arrested for homicide. Those are the absolute number. So what is the range? You can pause the video. The range is 20. So again, the range is the very simple formula is the biggest. What is the biggest frequency here? That's a 20, right? What is the minimum? That's a 0. Okay, the minimum is not 1, it's actually 0. So that would be 20. Okay, the maximum 20 minus the minimum 0. That's a range. Quite simple, right? And the good thing for the range is that it's so simple, straightforward, give you some limited useful information, easy to calculate, understand. The best side of the range is that it's just too simple. It's like the mode for central tendency we just talked about in the previous PowerPoints is that it's very simple, but it's just too simple. Okay, it's superficial and it doesn't really give a lot of information. Sometimes it can be misleading in understanding the actual dispersion is. So we have other two very basic measures of dispersion in a data set or in a variable. The first one we call the variance. Okay, the variance is a measure of dispersion. Now usually we use the S square. Now later you will know why it's S square. Okay, it can be only used with continuous data, whether it is a interval data or it is a ratio data, that the variance can be used on them. Okay, but it does use every number in a data set. It does use every raw score in the data set, and I will show you the formula and how to do the calculation for the variance. So the variance and the standard deviation, they call the standard deviation, we use a little s to represent standard deviation, are very most important measures of dispersion. And typically, in the papers or academic journal articles, the one you will see is the standard deviation. Okay, now you can simply guess like where the standard deviation coming from, right? So the variance is s squared. Standard deviation is a little s. So in theory, it looks like if we take a square root of the variance, you will get the standard deviation. That's the guess from the symbols. Now it's actually correct, okay, but we will talk about this in a couple of slides. So the variance is constructed from mean-based distribution scores. The very first thing before we calculating the variance is to understand the deviance score. The deviance score is very simple. So the deviance score for a case equals to the round number minus the mean of this sample. Okay, the round score minus the mean. And also, the variance formula for sample tend to produce an estimate of the population variance that is downward biased, especially in a very small samples. So in order to correct for this bias, we usually subtract 1, okay, subtract 1 from the number of the observations in the variance formula. So for the variance formula, now typically in this PowerPoint, we use the variance equals to the sum of the deviance score square and divided by the total sample size minus 1. Now, in some cases, you probably also see the bottom n minus 1 is written as the little n. Okay, sometimes it's just happening when you're seeing a large sample size or when you're seeing this one in a big population. But for the small one, we usually use the n minus 1 to correct this bias. Okay, and also if you kind of replace this deviance score with the original one, which is where the deviance score formula coming here, right? So you will get it's the round number of each case minus the sample mean, and you square this one, and then you add everything together divided by the total sample size minus 1. It's a very simple formula, and it is very easy to calculate. So here's the example. How do we calculate the variance here? So let's say we have the table shows number of felony jury trials handled by the prosecutor's office. We have 1, 2, 3, 4, 5, 6, 7 office, right? So we have 7 offices and trials. We have each office has different trials. Some of the offices are really busy, like the office F. It has 40. Some of the offices are really not so much busy, like they only have 1. So what is the variance, right? So here we calculate it as this way. So I already put the number here. So you will see these trials, we usually treat this one as the round number x, right? The office A, B, C, D, E, F, G, it means nothing. It's a nominal variable that only shows the name. And for this one, you can see the total sample size is 7. Okay, so on the second calculation based on the formula, you use the original x minus the mean of the x. How to calculate the mean of the x? The total sample size minus the the total number of trials minus the sample size. So if you add them together, that would be 102 divided by 7. That would be around 14.57. And you use the round number minus minus this the mean. So it's like 8 minus 14.57. That'd be negative 6.57. Okay. Since you do this one for each one and you square it, you square all the numbers. Therefore, every number is supposed to be a positive number, and you add all the positive number together. They'll be finishing this part, the top part. Excuse me. So the bottom part, as we said, we use the total sample size minus 1. So that would be 6. Okay, so 903 divided by 6, that would be 150.61. That is the variance, or the S square. Okay, so then the standard deviation, as I mentioned before, is the same is a thing that you always see in the papers or formal research articles, right? So the standard deviation we use is the little s or SD. Sometimes people use the STD as well, right? To represent this standard deviation. So the variance has a problem. It's a good measure about the dispersion of the data, but as you can see, it square everything. Why we needed to square everything? Because when we calculate the distance, some of the distance are positive, some of the distance are negative, and if you simply add those distance together, you see you will get positive and negative number mixed together. So you couldn't have a very clear or correct distance between the round number and the mean. Therefore, we square everything, right? As I mentioned, if you square everything, then everything become a positive. So if you add all the things together, positive things together, you will get the correct distance. But the problem with the variance is that to eliminate the negative numbers, we have to square it, right? So the variance is literally a square number. So the like the PowerPoint says, the variance is a good measure, but by squaring its deviations, we also square the unit in which it is measured. So it's a little bit hard to explain. So how to correct this way is quite simple. We take the square root of. Since we square everything in our calculation in deviations, so if we take the square root of the deviations, we solve the problem, and we can easily interpret the standard deviation here, right? So the standard deviation is the mean of the deviance scores. It's a good measure of dispersion among continuous data. The interval data or ratio data, interval variables or ratio variables. Okay, so if you put the complete formula here, the standard deviation will be the square root of the variance, and the variance those are look like a variance, and how you do this one in the raw score. Okay, it's very simple. So in order to get the standard deviation, the very first thing you have to do is to get the variance. Then you take a square root of the variance, you will get the standard deviation. It's just that simple. So this is the example. It's just the same example we just used to calculate for the variance. Now this time it asks you about the standard deviation, right? So again, the whole process is the same. We first take a look at how many offices we have, what's the sample size, then we calculate the mean of these numbers, and we use the round number minus the mean, square this deviance scores, and add everything together, right? So again, we will have the standard deviation as the square root of the variance, and variance, as we mentioned before, is 150.61. You take a square root of it, that would be 12.27. Okay, that's the standard deviation is in this example. It's quite simple as long as you know how to calculate the variance. Okay, so the standard deviation and the normal curve. The normal curve we mentioned in the um, previous PowerPoints is that the normal curve is look like a symmetric bell shape, right? On the left side is identical to the right side. Okay, so it's like a symmetric um, shape like that, right? Bell shape like that. So the smaller standard deviation suggests less dispersions, and the bigger standard deviation suggests greater dispersions. So if you put a picture, it looks like when you're going to get a small standard deviation, and you will get something like this. Okay, so when you get a big standard deviation, So it will be look like this. Okay, so the smaller standard deviation suggests less dispersion. So they are concentrated among like here, right? When the bigger standard deviation, they are spread. So they are not really concentrated here. Okay. However, whether they are big or small, it's normalized curve. So the standard deviation, standard distribution is at about 2/3 of the scores in the distribution within one standard deviation below and above the mean. Now, what does that mean? Now we're going to take a look at a very important graphs here. So this is the normal curve with the standard deviation. Standard deviation 0, which is in the middle, that basically is where the mean is. Okay, it basically is where the mean is, but also it's where the standard deviation 0 is. Okay, so you will see like when you see the standard deviation as 1, that's part of this area, right? This area. So if you take a look at this area, the area under the curve, that would be 19.1 plus 15 is about 34. I don't know why there is always coming from a line. Okay, 34. And if you take a look at the one from negative standard deviation here, and you will see this part, right? And still, since they are since it is symmetric, so left side identical to the right side, or you can simply calculate this is also like about 34%. So you will get to about 34%, and you add them together, it's like a 68%. Okay, 68 is sort of like 2/3, because 2/3 is about 66.666, whatever. Okay, so you can see here is like, what does this sentence mean is that about the majority of the scores line between the one standard deviation, whether it is it's between +1 standard deviation here and a -1 standard deviation here. Okay, so if the standard deviation is 2, then it goes to a bigger one. So we didn't put the thing in the PowerPoints here, but you can calculate what about the standard deviation 1 and the -2, +2 and the -2. So you will add this 34, there are another 13.6. Right, 13. Why there is always a line like this one? I don't know. So 13.6. So this side will be 13.6 as well. So that if you double it, if you multiply by 2, that would be about 27. Is that 27? 26, 27, something like that. Okay, estimated 27. So it's a 27%. Okay, so you add those two things together, you will get about 95%. So this also tells us a thing is that about 95% of the scores in the distribution line positive 2 standard deviation and -2 standard deviation. Okay, 95%. 95%, like all the numbers, 95% are within these areas. Okay, that is how you interpret the normal curve with the standard deviation here. So in terms of the relationship between the standard deviation and the z-score, will be covered in another PowerPoint. Okay, the z-score is also a very important concept. So that's it for the measures of dispersion.